If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where you are starting limits. So in this lecture we will see some of the basic theorem of limits and some standard limits. Okay, then let's see this. Okay, the topic is limits. So what is limits? So generally you will see that limits x tends to a. This is the way we pronounce it, this one. This is limit x tends to a. So one thing you have to be very clear before starting, that it doesn't mean x equal to a. It means we are going towards a, we are approaching towards a, but not equal to a. We are approaching to the point a as close as we can go, but we will not reach at that point. Suppose we say limit x tends to 2, that doesn't mean that we are putting x equal to 2. No. We are putting a number which is very close to 2. It can be 2.0000001, as close as you can think, or 1.99999. Now because we have only 2D, so we can either go left side or right side. That is the two way we can go. Either we can go 2.0001, that is in right side, or we can, suppose 2 is here, so either you can go 2.0001 or you can go 1.99991, because it is 2D. Suppose it had been 3D, then how to reach this point? There are multiple ways. Suppose this is a hilltop, this one, this position. So there are, you can go this way, this way, this way. So there, in that case, there are infinite ways. But you have only one point and you have only 2 dimension, because this one, either x-axis is the input. So you can move either left and right, because this is your input. So you can go either this way or this way. You can approach to either from this side or from this side. So one good example for this one, I thought this will be greatest integer function is the good example. You can recall you that staircase function. So box of 1.999 is always 1. You recall this one? Okay. So box, anything between 1 and 2, the output will be always 1. Anything between 2 to 3, output is always, box 2 is 2, box 1.999 is 1. So this you can see. Suppose I want to find limit x tends to 2 fx, means if I go very close to 2, then what happens? What value I get? So for that one, you need to approach from both sides. Then you have to see, and then we will conclude what is the limit. So first let me this is 2 minus, means I am going from left side. That means 1.99999. So if I put box 1.99999, then this monkey will, in which branch it will climb? This monkey will come here, because 1.999 will land you 1. So the output will be 1. So that means your output will be 1. Now if you go very close to 2 in this side, that is 2.0001. So anything above 2, it will reach at 2. Box 2.00001, what is the greatest integer function? 2. So 2 plus, that is you are going in this side, that will answer give 2. Both these are not equal. That means both are very close to 2. One is from left side, one is from right side. But both are not equal. So if these approaches are not equal, then we say limit does not exist. So for limit to exist, or you have to say the value, limit value is this one, these both sides approach should give me same answer. Then we say okay, if I go very close to 2, my answer is this one. Otherwise some of the people will go from left side, they will say if I go very close to 2, then I am getting 1. Some people will go from right hand side, they say if I go very close to 2, the answer is 2. So which party you will think, which party's voice you will listen? Someone will say 1, someone will, both are correct. So in that case we say limit does not exist. And it should be finite also. Both should be equal and finite also. You may have some situation of like this. Suppose this one. You may have, we will find some curve of this fashion. Suppose at x equal to 2, 2 minus 1.99, it is going infinity. At 2 plus also it is going infinity. So that is also, because limit should give me some exact value. It should be finite value. It should not be that both are giving me infinite. Then we will say if it is finite and they are equal, then we say limit exists. And this is known as left hand limit, LHL. This is known as right hand limit. You are going from right side plus you are going from left side. This is 2 plus, means you have to be very careful. 2 plus means 2.00001. 2 minus means 1.999. Okay, then some theorems on limits. Suppose this limit x tends to 0 f1x, limit x tends to 0 f2x, both exist, then some conclusion we will see. So if we start, before starting it, you remember limit is just like a press. Press has permit to go anywhere. Press, reporter, they can go by showing their pass, they can go anywhere. So limit is like that, they have a free pass, they can go anywhere. So suppose you have a addition of 2 functions, then it will be simply addition limit of first function plus minus limit of second function. So limit can go here, limit can go here. In both where limit will be you can split this one. Suppose they are product, so again limit of this one into limit of this one. So again it has a free pass. Divide limit of this, divide by limit of this. But here one thing you have to be careful, this denominator should not be 0, because otherwise it is undefined. So if it is power to the power, then limit of this to the power limit of this. So again it has a free pass. Suppose, provided that this should not be non-zero, because if it is both are 0, then 0 to the power 0 is undefined. Just after some time you will know there are 7 undeterminate form which cannot be determined. So that's why it is saying that both should be non-zero simultaneously. At a time, one at a time can be 0, but both at a time cannot be 0. So limit x tends to 0 fx to the power n. Again you can enter this limit inside and then to the power n. Same 1 by n also you can go. Here n is a positive integer. Why? Because if n is a negative integer, then it will come in the denominator. To the power minus 2 means 1 by. Then you have to be careful that denominator should not be 0. That's why they are saying positive integers. If n is even, that is half, that means square root. So generally what we will take output as a positive. Square root of something, generally it is always assumed that output we will always take positive. Now these are some theorems. Suppose f1 is less than f2 when x is near to x0. That is known as, in mathematical language, you will see this language in very often in limits, continuity, in these topics. Neighborhood of x0. Neighborhood of x0 means very close to x0, that is x0 0.0001 and something below that x0, that is like in 2 we say 1.999, 2 points. So very close vicinity, as close as you can. It is not that 3 is very close to 2, no. 3 is the neighborhood of 2. It is in the neighborhood, but that neighborhood doesn't make sense here. Here neighborhood means as close neighbor as possible. So for 2, the neighborhood means 2.000, 1.99999 to 2.000, as many 0 as you can pronounce or you can think of. So that is very close to x0. So don't think that 3 is also close to 2. Let me write 3 is also neighborhood. No, it is very close. And the limits on f1, f2 both exist. Then we will say as x tends to x0, as x approaches to x0, as x goes near to x0, all these meanings are same. If you go very close to x0 and you know that your f2 is always greater than your f1, then if you go very close to x0, then the limit of that function f1 at x0 will be smaller than limit. If you go very close to x0, you see your output is f1 output is this, f2 output is this. So you can easily say limit x tends to 0 f1 will be smaller than limit x tends to 0 f2. You can think of that. I have taken limit in both sides. Now if you have a function of something of that, f1 f2 is highest, then f1, then f then f1. That means f2 is this is f2, the upper one, then middle one is f, and the lowest one is the f. So f1 is smaller than f1 is smaller than f is smaller than f2, smaller than or equal to. When x is very near to x0, except possibly at x0, I am not going at x0, I am going very close to x0. And this f1 limit and f2 limit, both these limit exist, these two limits, both are equal. Suppose at this point x0, if you take the limit of f1, if you go very close to x0, your output is equal to L for f1. For f2 also it will be L, because they are touching each other, so both these are same. Then we will say that then fx should also be L, because fx is in between these two. So if this is also output giving L, so upper one, lower one is also giving L, so the middle one should also give L, because it is sandwiched between these two. So if upper one is also giving me L, lower one is also giving me L, so the thing that is inside that should also give me L. You can see the heights of 3 are all will be equal. So fx is sandwiched between f1 and f2. So that's why it is known as sandwich theorem or pinching theorem, because you are pinching f from upper and lower side. Or it is known as also squeeze play theorem. So whatever way you remember this one, very important, very useful also. If fx is a polynomial of odd rational fraction, you have seen what is polynomial, what is rational function, we have explained this one, and x0 is in the domain of f, then limit x tends to 0 fx, x0 is always, because in that case always, if it is a polynomial, it is always continuous, means it is continuously you can draw, you will see what is continuous, discontinuous in the next topic, continuity. So here left hand and right hand always give equal, and that is always, if you put that value directly on the function, you will get the answer directly for that polynomials and rational functions only. Now if you have a composite function f1 and f2, then limit has a free pass to go inside, then both side limit is not, because once you put limit here, your x will vanish. So that doesn't make any sense to put limit, another limit here, because you will not find any x here. So where you will put that limit? If I write one more limit x tends to x0, there is no x. If you do this one, all x will go. only values will come. So that's why you will directly calculate f1. So no need to write two limits here, only one limit one. But provided that this should be, f1 should be able to digest this one. That means this should be in the domain of f1. f1 should be able to take it. So you can say f1 is a continuous at this point, means if this value at this point, f1 should give some value. f1 should be able to take this value. Like your limit x tends to 0, some log of fx. So it is log of limit x tends. So what value of log can it if it is positive? So this should be positive. If it is positive, then only you can give this pass to free pass to this reporter. Limit will get free pass. Now some standard limits or some formula. So limit x tends to 0, sin x by x, tan x by x, sin inverse x by x, tan inverse x by x, all are equal to 1. So that's why I have not written separate formula. You can think limit x tends to 0, sin x by x 1, limit tan x by x 1, sin inverse tan inverse x by 1, that is always 1. Limit x tends to 0, x to the power n, a to the power n divided by x minus a is n, a to the power n minus 1. So this is trigonometry, this is algebraic or polynomial, this is exponential, a to the power x minus 1 by x is equal to log a. The similar fashion is e to the power x minus a is equal to log e, it will be, so log e is always 1, so that's why it is 1. This is logarithm function. So you have trigonometry, polynomial, so you can say these are functions, trigonometric function, these are algebraic functions, you can say this is exponential function, that is something power format, this is logarithm function, and the last one, this is an extra. So it is log limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Or the same thing can be done for infinity also, because if x tends to 0, then 1 by x goes to infinity. If you put infinity, then it will be 1 by infinity is 0, so 1 plus 0 0, sorry 1 to the power infinity. This is also 1 to the power infinity. If you put 0, this is 1, 1 by 0 is infinity. So both these are of 1 by infinity format. So for that 1 by infinity format, we have a very standard one that we will see in advanced level. If you like the video, then press the like button and please give your valuable comments in the comment section.